Hi everyone, let us discuss this example. In this example, we are in a search of a function which is continuous but not bounded on this interval, open interval 0, pi by 2. Let us find this function. Okay, so we define a function, okay, f on open interval 0, pi by 2 as f of x is equal to tan x. A very simple function I have taken, f of x is equal to tan x. You know that tan x means what? Tan x means sin x upon cos x. We know that sin and cos, these are always continuous functions on entire real line R. Okay, so clearly sin x and cos x are continuous on open interval 0 to pi by 2. Actually, these are continuous on entire real line R. So that's why obviously these functions are continuous on that open interval also. And one more thing, and cos x is not equal to 0 on 0, pi by 2. So we know that cos pi by 2 is 0. But see, this is an open interval, no? So you cannot take the end point. You can take the points between the 0 and pi by 2. You cannot take pi by 2. So that's why cos won't be 0 in this interval, right? Okay. So yes, let me write it here. So sin and cos, these are continuous and denominator is non-zero. So that's why their ratio is also continuous. So therefore I can write, therefore f of x, which is tan x, which is nothing but sin x upon cos x is continuous on 0, pi by 2. Okay, so the first thing is over, that function is continuous. Now the last thing is we have to prove that function is not bounded. So here f of x is equal to tan x goes to infinity as x tends to pi by 2, as x moves towards pi by 2, the tan x goes to infinity. See, in 10th standard we have already studied that table in which we have seen the values of sin, cos, tan, 0, pi by 3, pi by 4, right? So there tan pi by 2 is infinity, we have already seen. So tan pi by 2, as x tends to pi by 2, tan x tends to infinity. So therefore f is not bounded. F is not bounded on this interval 0, pi by 2. Understood? So therefore we got a function which is continuous but not bounded. Okay, make a screenshot of it, then we will stop. Thank you. Bye bye.